Yeah, hand it to Matilda. And then Matilda, we hand it up on. Okay, we're technically still in 9.1. Except it's going to be really quick. And it's going to be just what is a series. And a few problems. It's the end of 9.1. You did the homework for 9.1, and we're just going to do like a small little bit left. Thank you. Okay, 9.1. It's all about series. Well, the rest of it is all about series. Series. Let's start with the word set. Give me any set of numbers. Cool. 1, 3, 5. This is a set of numbers. A sequence, let's call it that now, is the set of numbers in a certain order. So order, not matter. In a sequence, order does matter. Let's say it was 5, 3, 1, because I want to go in descending order. It could be different each time. So order matters here. A series, new word, series, super easy. We take all of the numbers in our set and we're going to add all the numbers. So add all numbers in
What's the second one?
sequence. Yeah, I just shorten it. Add all numbers in the sequence. So this would be 5 plus 3 plus 1, which equals what? 9. And that would be the answer for this series. This is a finite series. There's finite and there's infinite. So series, that's just like a nice, easy way to remember this. But let's write the nice definitions for these. So series. We have the sum of the first n terms of a sequence. So we need the sequence to get our series. It is called finite series. So we have a certain number of numbers in our series. So finite series, or n partial sums. Two different words for it, but it's denoted as a1 plus a2 plus a3 all the way to whatever our a of n is, which if we write it nice and neat, we're going to have our n up top, our I equals 1 on the bottom. This is just a of I. That is a finite series. We also have infinite. Finite, this is infinite. The only change is that we do a to the 1 plus a to the 2 plus a to the 3 to some number, plus we have our a to the I, but it keeps going on and on forever. And we just change the top to an infinity sign. So we have to figure out what our sequence is first to get the sum of that sequence, and whatever that sum is our series. Sum of a series. Now, we did a problem yesterday on the board. We're going to start with that same problem, except maybe I'll change it a little bit so we're not doing the exact same math. Mine are always crooked. He was saying the other day that you guys have like really, really nice ones, and you do. I don't even do like the little up part anymore. Whatever. It is what it is. We'll do 3 over 10 to the I. I want you to find two things. Is this infinite or finite? Infinite. Yep. Infinity up top, that's what we have. So find the third partial sum. And number 2, I want you to find the sum of the series. We're probably gonna do 2 together. So this is a series that I've given you. I want you to find the sum of the first 3 terms of the series. So you gotta find the first 3 terms. What is our first n value? 1. Okay. Finish it up on the boards. In the same groups, or you can pick your own groups. Or you want me to pick the groups? Or random generator. You pick? Okay, pick your groups. Not more than 3. You found these terms roughly yesterday. Okay, I'm going to give you a little more information that would be in like 9.3.2, but we might not get to it for the AP. So let's do it now. There's a thing called a geometric series. Metric? Is it C at the end? Geometric series. A geometric series has a constant rate. It's going up by something each time. What was our rate in this problem? Yep, 1 over 10, which is the same as 0.1. What was our very first term? What was it? Yeah, 3/10, so 0.3. It's easier if we just do decimals right now. So a geometric series says that if our rate is less than 1, if the rate is less than 1, so that's a very important piece. If the rate is less than 1, then the infinite, I'm just going to put this on, infinite geometric series can be noted as this. Okay, when we have to 3 terms, this can also be written as s to the third equals 0.333. So that's 3 terms. So summative notation is also s. So they also use summative notation in your thing. So s equals our first value over 1 minus r. A1. So what does A1 mean? A1, yep, is first term. And R is our rate. So we're kind of jumping ahead. Geometric series. A good thing to remember. A geometric series is most of the time going to have an exponent of like, that's what we're going by. So our rate has an exponent. So if we have like 1 over 10 to the n, or if it's, I'm trying to think of another one, 2 over 3 to the n, or n is in as an exponent, it's probably going to be geometric. Has a constant rate each and every time. Here, what is my rate in this one? What's my rate in this one?
Shoot. You wrote a different one.
No, this is the same one. These are 2 different ones. What is my rate? Sorry, I'm going to change it so maybe it's less confusing. These are 2 separate problems. What is my rate in this one? Yep, 0.1. What is my rate in this one? That's my coefficient up front. Just 3. That's what the n is affecting. So my rate would be 3 for this one. Yes. Okay. But my rate isn't less than 1 in this case, so I can't use this formula. I can only use this formula when the rate is less than 1. Okay. Let's apply it to this problem. Because, okay, it can get a lot uglier. than this. This was a simple one, but it can get ugly. So I use this formula for this problem. I have S equals, my first term was 0.3 over 1 minus 0.1, which we said our rate. What does that equal? Tell me where to stop. 0.3, yeah. My handwriting gets bad on this thing. Because it's not like pen and paper, so it just glides. It doesn't have the friction. So 1.3 over 0.9. What does that equal?
Wait, no, all 1/3.
Yep, it should equal 1/3. So you can use this formula to get to this a lot faster, as long as it is a geometric series. Otherwise, you're going to have to keep doing the adding and on forever. Okay. Cool. A little show to the future. Let's do a harder example. Let's do infinite of n equals 1 of 5 times 1/2 to the n. And I want you to find two things. I'm going to do that so it's different. Find the fifth partial sum. So that partial sum is now S5. You can just denote it as that. Same thing as S to the 5. So a fifth partial sum, so S to the 5. Okay, 2, find the sum of the series.
If 4 minus 5 halves, you do it with the first term. So when you do 5 times 1/2 to the power 1 equals 5 halves. So you always do it by the first term.
So our first term right here was the first one you calculated. So that's 5 halves. And then what's the rate of change? What's affecting? What is n affecting? 1/2. And then we do take this, so S equals 5 over 2 over 1 minus 1/2. So that's 5 over 2 over 1/2. Oh, I haven't done this with guys. Who knows keep, change, flip? Who calls it something else? Okay, well that's logical. But yeah, keep, change, flip. A lot of people have not heard that in like the algebra classes and everything. Yeah. Yeah.
Learn that. I don't know what it means, but I
Oh, okay. Ready? I love it. So you keep your numerator, put it over. Wait, you change division, because that's division, to multiplication, because it's reciprocal. And then whatever the fraction is below, you flip it. So keep, change multiplication, and then flip the fraction.
Yeah, I just say multiply.
You can do that too, yeah. Kentucky chicken fry.
But
Oh.
Kentucky chicken.
So 5, we're good. Do we want one more or? Yeah, good. Okay, cool. So, do we need homework problems to practice? Okay. It's just going to be 9.1 again. So 9.1, homework. 9.1, page.
Until then, wherever.
What else do you want to do? Okay. Oh, homework 9.1. It's going to be short and sweet. Yep, homework. What's that?
Is this thing also this thing from Miss Jarvis? That's from Miss Ortiz. Really?
Yeah.
We got it from Miss Jarvis. I don't remember Miss Ortiz. But she might have done it. But it's this thing where you just say it on the first day of each month to get good luck, or like good luck or something.
Oh.
Like rabbit. And if you say it before someone they can't say it, it's like something like that, right? I don't know.
So who has the good luck now?
Christina, she said.
Oh. Let's see. We do 95
Same direction.
and 96. Okay, that's it. If it takes you more than 20 minutes, come to study hall. Yeah. Check. Guys, you can make it so much easier on yourself if you check to see if it is a geometric series. You can just use the formula. Okay. Well, we have more time. Now, there might be a geometric series. But guess what? There's also a different type of series. We'll sequence this.
Here. We're on the right page. You are on the right place.
Yeah. Yeah.
614.
6:15. That's sweet.
Oh, are you working on it now?
Yeah.
Oh.
Oh.
Yes. We're talking about sequences still. Arithmetic sequences are going to be very close to regular sequences, but they have a special thing about them. So a list of numbers is a sequence. So a list of numbers.
Is it frozen? You should.
Yup. Where, this is important, where the difference between consecutive terms are the same. Are the same and are a constant. Just gonna call it C. All the same. We're gonna leave it there. All the same. So A1, A2, A3. I want to stop there. I want to keep going. Keeps going to the A, to the N. Keeps going forever. The difference between these, so difference. We denote this as a D. What are two consecutive terms? Yep, so I take A2 minus A1. That should be the same difference as A3 minus A2, which is the same as my A4 minus A3, and so on and so on. Forever and ever. D is called a common difference. D, common difference. If we have a common difference, then it is an arithmetic sequence. And then there are some rules, just like the geometric series, that can make questions a lot shorter. So we're kind of doing the same thing we did when we started sequences. I'm going to give you an example. You're going to tell me if it's an arithmetic sequence. I hate that word. -2. No, +2. I do that all the time. I annoy geometry so bad when I erase definitions and then write them again because I don't like how the book does them. -3. And it goes on and on forever. What is this an arithmetic sequence? If it is, what is the rule to the sequence? We did the rules a lot before. Is it?
Subtract 5.
So if I subtract 5, where am I starting at though? So 2 minus 5. Is that my rule? That's just going to get me -3. Okay. I think I need an n in there somewhere. Okay. Say we get 2 minus 5n. Okay, so let's put a 1 in there. 2 minus 5, 1. That gets me 3. Okay, 2 minus 5, 2. That's 2 minus 10. That gives me -8. What was my first term? 2. Can we get 2 from this? If I put in 0. Very true. But we always start at 1. I think we gotta switch it up a little bit. So we start at... So change this guy. So if I put in 1, I get 2. Yeah. Okay.
I think we need the n minus 1 and not just n. Maybe.
I think still keep with the just n for now. Yeah. I like this one. How do I get from -7 to 2? -3 to 2. I gotta add 5 somewhere in this problem. Where should I add it to? What? Add 5 to the 2. So that means we have 7 minus 5n. So let's start with that. Plug in a 1. What do we get? We get a 2. Okay, let's see if it keeps going. 5 to second power. Second. So that's 5 minus 10. And we got -3. And it should keep going on and on forever. So our rule, is this an arithmetic? Yes. I'm not even going to write it anymore. Yes, it is. So yes. And rule is 7 minus 5n. They're going to ask you after this to like find the 10th term or something. So that's why knowing the rule is important. There's a shortcut to also doing that. But first, we're going to do a few more examples. I'm going to give you 2 more. We got 8 minutes left. Do you want to do them sitting down or up on the boards? I hear 1 vote for sitting down. Sitting down? Okay, we can also just do individuals on the boards. You don't have to do groups on the boards. Would you like sitting? Yeah.
I just like having it in my notes. That's why I don't like the boards.
Okay. If you want to do it on the boards, you can do it on the boards. If you want to do it on the ground, not on the ground. If you want to do it in your seats, you can do it in your seats. So let's do... People have done that in this class before. Don't know why. 1, 5 over 4. 3 over 2. 7 over 4. So is this an arithmetic series? If so, what is the rule? This goes to 12:30, right? Yeah, perfect. Okay.
Well, I think the third one is. The second one's not. The third one is cube root. Yeah, right?
Wait. Erase the negative.
No, but
5 over 4.
so then the second one does.
Erase the negative. My bad.
So.
You should find the difference between one.
Oh, so it
Just see if it's an arithmetic series.
That's 7 points.
Hmm?
By
No, no,
it
go to the
defeats
addition
by
or
1 point.
subtraction.
Wait for what? I think it's a fourth in each time. I think so. Wait.
Okay. Is this an arithmetic sequence? Yes. What is my rule? Yeah, I would n plus 3 over 4. Yep, same thing. Do we all get this rule? Yeah. It's okay. I have a shortcut for you. So we don't have to keep making up off the heads. Okay, third one. Is it an arithmetic sequence? No. Because it will be like n to the third. Okay, n in all of these. N and n. It's not an exponent. Right? It is not an exponent. It's going to happen a lot with these series. If it is an exponent, it's probably going to be a what type of sequence series? Geometric. Yep. We're kind of skipping with geometric. Geometric is 9.3, but I want to get you used to the idea. Okay. What's the rule to make this super, super fast? So, the nth term of a arithmetic sequence. This is finding that term. Has a form of a to the n equals a1 plus or n minus 1 times d. What is a1? First term. D is a new concept. What was our D? Yep, a common difference between each term. Common difference. So that can help us find it. Yeah. So let's take, did you like the first one or the second one better? You pick. Second one? Okay, for number 2. Find the 15th term. Up there. So an n is what in this problem? 15 equals our first term. What was our first term? 1 plus 15 minus 1. What was my common difference? 1/4. Boom. So you can find that term.
Can we not just put it into the thing we made?
This is how we make that thing. Yeah. So you don't have to make that thing anymore. You can just use this. Okay, we won't have homework for this.